we will discuss how to run regression analysis in Excel. Assume we have three independent variables, service quality, experience, and employee incivility, and one dependent variable. Our hypothesis is service quality positively influences customer satisfaction, service experience positively influences customer satisfaction, and employee incivility negatively influencing customer satisfaction. We develop a dummy data on all four variables on a sample of 50 respondents. So this is the dummy data for 50 observations. The first thing, we have to calculate mean value for each variable. So here we go, insert a column and calculate average of all these three items. Service quality is measured by three items. So we calculate the average and we drag all to 50 observations and average is calculated for all. Repeating the same step is equal to average and select all these three items and enter. Drag. Employee incivility is measured by 5 items. You can see 1, 2, 3, 4, 5. So repeating the same step. Enter and it will calculate for employee incivility, and finally average for customer satisfaction and rate. Now we have mean value for all variables. Now this observation we don't need anymore. We have to play with these mean values only. So therefore, in second step, what we are going to do is to copy mean values, go to other sheet and paste here. Right click, paste here, paste special and paste. Now the name of variable for this mean value is service quality. So we copy and paste here. Repeating the same step, copy all mean values for experience, paste here, copy the name of variable and paste. Employee incivility, mean values, paste special, copy variable name, and finally customer satisfaction, paste special, name of variable and paste here. Now we only have to work with these values. It is always better to limit your values to 2 decimals. So we select all, right click, go to format cells and number 2 decimal. Okay, now this is same for all and symmetric. In next step, we have to run regression analysis. Remember that this is y, this is x1, this is x2, and this is x3, meaning these three are independent variables and one is dependent variable. To run regression analysis, we have to go to data. On the right top, you will find out data analysis tool. Click here, go to regression. Okay. Now define input y range. This is our y, that is customer satisfaction. So we will define that is selecting all mean values, and all values are here. In the second one, input x range. You know we have 3x over here, x1, x2, x3. So we will select all together. We also want these labels to appear in our regression output. So click here, and we want 95% confidence level. Now, there are two options. You can define your output range in this sheet here somewhere, but I want it in separate sheet, so just leave as it is and it will create another sheet. After this, you can go for normality plots, residual plots, residuals, whatever the values you want. But in this video, we just want to discuss regression. So I will limit over here and just click OK. Now you observe here, it created another sheet and our regression output is mentioned here. Now we have to interpret the output. You find three different tables here. The first one is regression statistics. It is always better if we limit our values to two decimals, then it will be easy for us to create meaning of it. So let me do two decimal here, all two decimals. Now the first thing is correlation. This is multiple R correlation. It defines how variables move in relation to each other. You can see here the correlation between the variables is 0.69. The second one is R square. This determines the coefficient of determination or covariance. This is also called as covariance. It defines the proportion of variability in Y that is explained by independent variables in the model. And we have three independent variables. So this tells us that what is the proportion of variability in customer satisfaction which are explained by these three variables. Then we have adjusted R square. This is more reliable as it takes into account sample size, and also later you will find out some variables may not have significant influence. So this is sometimes better predictor, and it can give us a better meaning. Standard error. This measures the variability of actual Y from predicted Y value. This is same as standard deviation. And this is the last one, that is observation sample size. This one is ANOVA table, analysis of variance. Analysis of variance is very important as it tells us about the probability that regression output is not by chance. Here we have degree of freedoms. Degree of freedoms affect t-test, its values, f-test, and adjusted R-square. It takes into account sample size, adjusting normal distribution with lower sample size that have wider tails which increase the statistical probability of unlikely events. The first value tells about number of variables under investigation, especially the independent variables. So we have k is equal to 3, This is residual n minus k minus 1, that is 50 minus 3 minus 1, and this is degree of freedom n minus 1, that is sample size minus 1. This is sum of square and this is mean square. The f value is also very important as it determines if regression analysis is significant or not. And this p value takes into account the f value. This p value, the significance level, takes into account this f value and tells the probability that the results occurred randomly, not by chance. Then we have main regression output table. In this regression output table, we have to decide whether our hypotheses are spotted and what is the influence, level of influence. So for this one, we will create two more columns. One is result and other one is hypothesis. Now, first we have to read this column, that is P, and P value for our service quality variable is 0.00. If the value over here is less than 0.05, the result is significant. It means that service quality have a significant impact on customer satisfaction. In the second one, service experience, the value is not less than 0.05, rather it is greater, that is 0.21. It means that it is insignificant. This means that service experience do not influence customer satisfaction in our this dummy data. And finally, employee incivility have significant impact on customer satisfaction because the mean value is 0.07. Now here are some interesting things. We have to decide whether our hypotheses are spotted or not, and we have to refer back. We predicted service quality positively influence satisfaction, and we have to observe now over here sign. So there is no sign, it means that there is a positive sign. So our hypothesis is supported. In second one, we predicted service experience positively influences customer satisfaction. But in this case, there is no impact, no influence because p-value is greater. So our hypothesis is not supported. Finally, we predicted employee incivility negatively influences customer satisfaction. But interestingly, there is an influence, but there is no sign. It means that there is a positive sign. So this means that employee incivility on this data positively influences customer satisfaction rather than negatively. Despite this is significant impact, our hypothesis is not spotted. So these are the beta coefficients which tells that when we increase service quality by 1 unit, there is an increase in customer satisfaction by 0.34 unit, which is significant change. But in service experience, you can see when we increase 1 unit in service experience, there is only 0.13 change in customer satisfaction, which is not that much high. But in employee incivility, there is still significant change because if we increase 1 unit in employee incivility, there will be an increase in customer satisfaction by 0.26. But we predicted here there should be a decrease, but this is opposite. So therefore we say our hypothesis is not spotted. This all about regression analysis, and as I said, this R square is telling the magnitude, and we have to also explain in our findings about the cumulative influence and the rate of change of in customer satisfaction caused by the service quality through our scale. That's the end. Thank you very much.